Okay, fine. So my screen visible?
Yes, sir.
Okay, great. So fine, guys. So yesterday's session. So if we see what all we have studied, so we have seen majorly on the categorical plots, right? In categorical plots, we have seen these plots: strip plot, swarm, box, violin, bar, point, count. Okay, and then fine. So now there are like few things we are going to discuss today, and the first thing is something called as using histogram and KDE plot. We are going to see bivariate analysis. Okay, so we have seen already histogram and KDE plot in the distribution plot section. Okay, we are going to go one step back and see how we do bivariate analysis using these two graphs. Okay, it's very simple. So I quickly show you. See here, guys. When we were studying histogram, we understood this is how the histogram looks like. Correct. So the way how we draw from CMOD library is simple. SNS dot histplot, right? Data and the x-axis. So this is a histogram for total bill. Now, when you do analysis on this single column, fine, it's called univariate analysis. In the sense, one column. Okay, because we're checking on only one column. Fine. But using histogram, it's also possible, okay, to analyze two columns behavior at the same time. Okay, so for example, see here, this is for total bill and this is for tip, both individual histograms. Now we can also combine these two in this way. So the same way, same thing you can say data tips, but over the x I'm giving total bill, or the y I'm giving tip. Okay, now this is how histogram looks like for both the columns, and this is called bivariate analysis. Okay, bivariate analysis, because you're using this graph you can understand the combination of two columns. So if you see here, the color shades will tell you the frequency of these both columns combination where it is having maximum. For example, over here if you see, this is a darker and it is around something 15. Okay, on the x-axis, that means total bill, and it is around just 2.5, or yeah, just about 2.7, something like that on y-axis, that is tip, right? So the combination of these two is the high. Fine. So the total bill with $15 and the tip of 2.7 or some $2.5 is having the maximum combination. Fine. So if you go above, fine. So if you see over here also, in the total bill, the maximum is the 15. Maximum in the sense with the frequency, right? In the histogram, what will be y-axis? What are we going to plot against? It is a frequency or the count. Fine. So $15 was paid maximum number of times. Okay, when you see the total bill. And now if I come down tips, if I see, it is just this one is the highest, right? So what is this? This could be like, let's say 2.2 something. Okay. Now that is paid maximum. Fine. So when I plot both of these graphs together, I get that combination like 15 and this some 2.2, stating that these two are having the maximum frequency. Okay. So and some other graph will have the some light color indicates it's a lower frequency. Almost most of them are light, but if you see on the dark, I would say this could be the first, and this might be the second, this third, fourth, fifth. Okay, these combinations are having the maximum frequency. Okay, fine. So similarly, the bivariate analysis can also be understood using the KDE plot also. Okay, so if you see the KDE plot, kernel density estimation plot, which we have seen in our first session of Seaborn. Okay, so you have K equal to total bill. This is a simple distribution graph of total bill. Okay, KDE plot of total bill. Agree? And now this is tip KDE plot. Okay, now if you combine both total bill and tip, right, over here, the graph looks something new to us. So if I show you, this is a graph. Okay, so the way how you need to understand is the gap. So wherever these what do you say, these circles or these patterns are closer, fine. So there the frequency is high. Okay, so over here, okay, they're very closer. Okay, next over here they're a bit closer, fine. So this says the same thing. So if you see over here, it's very close, fine. So around 15, fine, and over here it is also close. So this is something around 2.2 and some 15, fine. Total bill 15, 2.2, you will get some similar results. So this type of graph is also called as bivariate analysis. Why? Because you are trying to analyze two columns combination at same time. Okay, is that fine, guys? Did this make sense?
Yeah, Santosh.
Okay, fine. So you can change the columns names, and you can also try different combinations and try to understand the pattern. Okay, fine. So now next thing is, next thing is something called as facet plots. Okay, now, facet plots are not new to us. We have been seeing it from the first session of Seaborn, but the only thing is I did not use the name facet plots. Okay, but now it's time to use the facet plots name. And if I show you what are facet plots, mm, yeah, so these are the graph. If you remember, we have used this column and row combinations. Agree? So instead of seeing everything in one graph, okay, we have used column. In column, what type of data you want to see, okay, and in row, what type of data you want to see. Okay, I hope you remember this combination from day before yesterday. We have used, and yesterday session also we have used. Okay, so what happens over here, and when I say column equal to 6, that means it will have male and female. So in the each category will be considered for one column. So this column is completely for male and this column is completely for female. Okay, so if I go down, so see, this will be again female, male, female, male. Okay, so that is defined by this column. And row I have specified as day. In day we have Thursday, Friday, Saturday and Sunday. Okay, so each row will be considered for one day. So as you can see, this is for Thursday, and this is for Friday, and this is for Saturday, and this is for Sunday. Okay, so you get a matrix kind of thing, fine. And this type of graphs are called facet plots. Okay, FACET, facet plots. Okay, guys, fine. So just remember the name. Okay, fine. So we have already discussed so many facet plots. Okay, so the name we did not use, but if you see over there, there is a facet plot, and I think somewhere above also. Huh. See, this also, wherever you see the row, wherever you are mentioning the column and row parameters, right? So that comes under facet. And also you can see the Seaborn is also telling us this is a facet plot, facet grid. Facet grid is a different, okay? It's also, you will see what is facet grid, okay? Uh, okay, so this also, see, facet grid, facet plots, fine. So when you specify column and row, that comes under facet category, okay? So remember that facet plots, okay? And after that, now let's continue with the yesterday's continuation. So yesterday we have seen violin plots, right? Okay, so yeah, so did we see Point plot we have seen, right? Can someone remind me? Hmm? Did we discuss this graph yesterday?
Yes, I guess.
Okay. And count plot we have discussed.
Yes.
Okay. And this graph is also be discussed. Okay. This is also facet graph. Okay. So because you see you are specifying column and row. Fine. And this is the box plot. Okay. Now facet is a type of, it's not a type of plot, guys. It's a type of design, how in which you want to see the graphs. Fine. So you can use it for any kind of graphs. Okay. You can use it for box plot, you can use it for violin plot, you can use it for histogram, anything. Okay. Now this is a facet plotting for box plot. Okay. Fine. Fine. Next thing is what we have called as regression plots, guys. So this is yeah. Say, Karthik. Okay. So see, next thing what we have is a regression plot. Now this is not a general type of plot actually. Okay. This is related to a specific algorithm plot. Okay. And when we are going to study the ML algorithm, the first algorithm we are going to study is called as linear regression. Okay. Linear regression. Fine. So this graph is related to this algorithm, but you don't need to know the algorithm as of now. Okay. But I will just try to give you the overview of this plot. Okay. I'll just give you the overview of this plot and we'll see. So see here, the way how you are plotting is simple. SNS.reg plot. What is this? Regression plot. Okay. Inside this, I'm saying data equal to tips. Okay. And total bill and tip. Okay. Total bill and tip. Okay. So now you need to understand few things over here. Okay. Focus over here. So this will be helpful for your ML also. Okay. So, but see guys, now when I say, so I'll be speaking only from this plot perspective. I will not go into the algorithm point of view. Okay. That will be confusing as of now. Okay. But over here, what happens here is, see, I'm saying draw a regression plot for this data using these two columns, total bill and tip. Okay, only these two columns. Okay. So first of all, if I plot those two columns, first of all, what happens for these two columns, a scatter plot will be plotted. Okay. So forget about this line as of now. Forget about this line. Okay. Only focus on this dots. How did we get those dots? These dots are scatter plot between total bill and tip. Okay. So I'm just assuming. Okay. So these are my, this is my scatter plot. Cool. And on the x-axis, I have total bill. And on the y-axis, I have tips. Okay. I hope it's clear till this point. Now, what does regression plot do is, the basic idea or the concept of regression is, listen here guys. Regression means it will try to generate a line. Okay. Generate a line so that the goal is to pass through all these points. Okay. See, I repeat. In regression, linear regression, okay, the main point is to draw a line, to generate or produce a line such that it passes through all these points if possible, or pass through maximum number of points. Getting, see, now if the dots are in this way, okay, if the dots are in this way, in a straight line, then obviously you can draw a line. But if the dots are scattered over here, so obviously one single line cannot pass through all these points. Agree? So obviously, yes, Risha. Saying something? Okay. So one single line obviously cannot pass through all these points because these points are not in a straight line. So the next possible option is to pass through maximum number of points and to be closer to maximum number of points. That means what? I cannot pass through all these points. So wherever it's possible for me, okay, wherever it's possible for me, I will pass through those points, making sure that I am as much closer to the remaining points. Okay, I'm as much closer to the remaining points. Okay, so see guys, if you're not understanding, ask me doubts, but at this point, if you're not understanding completely also, that is fine. Okay, don't get worried. Okay, but just understand the basics that with common sense, our aim is to draw a line which passes through all these points. Now that is not possible. Okay, now what is my next option? To pass through, to be as close as possible. Okay, to be as close as possible to all these points. Okay, now when I say as close as possible, see what happens, guys. Through these points, I can draw how many lines? I can draw infinite number of lines. Okay, so this will be one. Okay, and now if you calculate the distance from each of this point, see guys, now this is my distance from this point, because this point is passing through the line. Okay. So the distance is 0. Okay, but this is away from the line. This is my distance. This is my distance. This is the distance. Like that, let's say I have 10 points. So you will have 10 distances. Okay, 10 distances. Agree? But you will have 10 distances. In that 10 distances, some distances might be 0. See, this point distance will be 0 because this is, what do I mean when I say distance? The distance from the point to the line. Okay, the distance from the point to the line, I'm checking. So let's say there are 10 points and you have 10 distances. In those 10 distances, some of the distances might be 0, like these points, because this point is on the line. So the distance will be obviously 0. Okay, and some of the distances might be less because these dots are very near to this line. So the distance will be very less. And some of the distances will be more. Okay, this is very far away and this is very far away. Okay, this will be distance more. So when you add all those distances, you will get, let's say, distance d1. Okay, for this line 1. Okay, let's say this is line 1, and for line 1 the distance is d1. Is this clear till this point?
Yes.
Yes, sir.
Yeah, clear, right? But just make sure you understand everything crystal clearly, guys. Okay, because see, from mostly today's class or tomorrow class, when you're starting ML, right? So don't put any doubts in your head. I'm saying, so whatever, if it is silly thing or if it is a small thing, even if you feel, just put it out. Okay, because you're going to learn many things in one single day. Small things. Okay, very interrelated things. Okay, but very useful things you are going to study. Like starting from tomorrow. Okay, so what happens if you keep small doubts, right? So that will slowly become bigger doubts and you will not understand the bigger things. Okay, so you can ask in the class, or if you don't want to ask, you can put it in the chat, or you can research yourself, and if you're not getting, you can ask some way. Make sure that the doubt is clear. Okay, fine. So now I hope it's clear now. But this line is there, right? Who is going to decide that this is the best line? Okay, because if I say this is a line, now Meghana will say, no sir, I don't want this line. So she will come and she will erase this line. Okay, so let's say all this are gone, fine, and she will say, sir, I will say there is some other line. Okay, this line should be the best line. Best line in the sense what? Which is closer to maximum number of points. Okay, So she will say, so see here, your line, earlier line was passing through only 1 point. Okay. But my line is passing through 3 points. Okay. Now that is L2. Now L2 also, again, you will calculate distance from all these 10 points. Fine. And in this time, 3 distances, distance 1, 2, 3, these 3 will be 0. Okay. And but there are some distances from other points. Okay. So you will add all those, you will get overall like small distances and everything. Like when you add the complete distances, you will have D2. Agree? Clear till this point?
Yes, sir.
Right. But again, let's say there might be one more line. Okay. Sirisha might say, so no, sir, because what will happen here is, so when you are drawing a line over here, okay, so it might be passing only 2 points, but it is closer to this point, and let's say this is closer to this particular point. Okay. But when Meghana is drawing a line like this, it might be passing through 3 more points, but the distance from this point is increasing, because this distance from the first line is this much, but from the second line it has increased. Okay. Like that, this is increased. Okay. For example, this is increased. So some distances are increasing. So she might argue. Okay. So like that, now the point here is like that, you will have infinite number of lines. Okay. So Karthik might say this one, I might say this one, you might say this one. Okay. So you will have infinite number of lines which can pass through these points. Okay. And very closer points also you can draw. Closer lines also. Fine. So now the goal of linear regression is mathematically to calculate that particular line such that the distances, okay, for example, the model. So now I'm not going into model things, but ultimately when the output of linear regression means a model will be generated. That means what? Internally, with some mathematical calculations, it will generate a line. Okay. So let's say this is my line. Okay. This is not straight, but just give me a second. Okay. Some random line I'm drawing. Okay. Let's say this is my line. Okay. Which my script, Python linear regression script has given me. Okay. Now, the beauty of this line is, okay, when it is generated, now this line will be the line which is nearest from all the points as much as is possible. I mean what? The distances from each and every point when you do, let's say this line is just L. Okay. You will get distance D. Now this D, that means the distances of each and every point from this line will be minimum when compared to any other line. Okay. You draw 1,000 lines, 1 lakh lines, but the distances which you are getting will always be higher than what the model has given you. Okay. And that is our goal. Our goal is what? If at all you are having all the points in linear, so obviously you can draw a single line and the distance will be 0, because the line is passing through the points. There is no distance between the points and line, 0. But this is not practically possible, because it is very rare that you will find any like all the points scattered in a straight line. So this is not practically possible. This is only theoretically possible. But what will be the practical case? It will be scatter plot, scattered all over the space. But now here, so obviously you cannot do justice to one point, because if you draw a line to this point, it will just make justice to this point, but it will fail for this. If you focus on this, it will fail other. Okay. So obviously you cannot focus on one single point. So what is the best possible option is to be as closer as possible to all the points. Fine. So somewhere over the middle. Okay. It might pass through one of the point, but it is the distances from each of this point when you consider. Okay. So that should be minimum. It obviously cannot be 0. Okay, here it will be 0. Here the distance cannot be 0. Okay, it will be some other value will be getting. Okay, but what are the value you are going to getting? That should be minimum when compared to any other line anybody draws. Okay, so that's what the model gives you. So when you give this line, when the model generates this line, fine, when the algorithm generates this line, so the distances when you calculate these distances, okay, from this line, and when you add up, which you get D. Now this will be minimum. This will be the minimum distances when compared to any other line. You draw any other line, okay, your wish, you draw any other line. When you calculate the distances, that distances will always be greater than this distance, because this is the minimum distance line. Okay, are you getting, guys?
Yes, sir.
Yes, clear, Karthik?
Clear.
Yeah, Santosh.
Okay, so you're understanding the logic, right? Like, this is like slowly we're entering the ML concepts, but I hope you are understanding the logic. Okay, see guys, ML is mostly max concepts scenarios. That's it. So code part, it is very, very less. Okay, I will go. I'm going to discuss this tomorrow. But ML, even in the interviews also, they will just ask you about the algorithm, how it works. That nobody will ask you to just generate or write the code. Okay, so once you get the job, that's different. But when you are working, when you are learning, or when you are trying to prepare for the interview, right? So it is mostly about the algorithm, right? How does it work? What is this line? How it will find out the minimum values? Okay, so something related to this will be asked. And also forgetting about the interview as of now, even when you're learning also, the code part is nothing. So tomorrow I will show you the whole end-to-end ML project. A small simple problem can be solved in just 10 simple lines, exactly 10 lines, sometimes less than 10 lines. Okay, so code part is nothing. Okay, at least in the for the beginners in the initial stage, developing a small ML model is nothing at all. Even a 10th class students can also do. Okay, but to understand the behind the scenes of the algorithm, max, okay, and different logics, that is where will create a difference for you. Okay, so fine. So I hope that is clear. Okay, so now that is how a line will be generated. So that is the importance of this line. Okay, so the line what we are seeing now, going back, so the line what you see over here. Okay, so if you understand, see, first of all, just forget about wait, it would be better if I draw a scatter plot. Okay, so how do you plot a scatter plot? So now start. Okay, now this is a scatter plot. Fine. So if you see this scatter plot is same thing, but the size is bit smaller. Okay, so this is the same plot. Now on this plot, I need to draw a line. Okay, so why? Because I'm using regression plot. Fine. So when I want to draw a line, so, and what is my goal, guys? Can someone tell me? I'll be very happy. So what is my goal when I'm drawing a line?
Distance should be minimum.
Distance should be minimum. Perfect. So obviously, I will be stupid if I draw a line here. Okay, because the distance will be maximum from each, and it is not doing justice for any point. I cannot draw a line here. So with common sense, I think I will be drawing somewhere in the middle. Okay, that is for sure. But it should be very accurate, because just few small millimeters also there might be another line, and that this second line might be possibly better than the first line or a bit above. Okay, so manually it's very difficult for us to do. Okay, so obviously we need the help of some algorithm. Okay, so, and also it makes sense if you see there is more density over here. Okay, there are a bunch of points located over here when compared to here. Okay, so obviously my line should pass through these points. Okay, so I cannot draw a line, okay, like this, because I will be doing justice to only few of the points, but I'm losing many of the points. Okay, but the goal is majority. Okay, it's just like voting, right? So even in the elections also, majority wins. That doesn't mean minority is like left out, minority is useless. But the point in the voting, what is the point, guys? Okay, you can understand it as from the voting analogy. So if you are having, let's say if you are having what recently we had elections, right? So overall 100 population, fine. So obviously everybody is not going to vote for a single person. Okay, so whoever wins, whoever gets like above 51% of votes, he will be the CM, he will be the leader. What does that mean? But let's say you are having like 40 like he got like 70% votes, and 30% votes gone to the opposition party. Okay, now because he got majority of the votes, now he will be the leader of the state. And what happened to these 30 people? So will there be any injustice to them? So possibly no, but the point here is, since he cannot do justice, okay, so since we cannot do justice for all the people, okay, so at least we'll be going with the majority, right? So what does the election commission say? He will say like, see, obviously you're not going to get 100% majority. It's impossible, right? So we need to go with the maximum number of majority people. Fine. Same thing like that. Obviously we cannot do justice to each and every point. So, but our aim is to do justice to maximum number of points. So if we draw a line here, obviously we are doing justice to minimum number of points. No, that's not the goal. So that's why a line should be, okay, sorry. A line should pass somewhere around here. Okay. So this should be a line. So fine. So now this is for scatter plot. So when you do regression plot, so first internally it will draw a scatter plot and see it has given a line. So see, this is the line. It is saying this is the line. Fine. So which when you calculate the distances from all the points, the distances from, let's say, like 100 points, right? So 100 points, some of the distance will be 0 because this line is passing to some of the points, and some of the distance will be high, low, etc., etc. Whatever the distance you say, like let's say 100 points, right? D1, small d1 plus d2, like that. If you do d100, 100 points distances, you will get some value. Let's say I'll call it as capital D. Now that capital D will be the minimum. That's the point. Will be the minimum across all other lines. Okay, even if you draw like 1 lakh point lines also, okay, wherever you want to draw, so the distances will be obviously greater than this D. Okay, but this D will be the minimum. Okay, how I'm going to say, because that's from the algorithm, and that is the beauty of algorithm. Fine. So when it gives mathematical evidence and mathematical background, so that will become a statement kind of thing. Okay, fine. So now that is regarding the regression plot. So what is the regression plot? What it is doing? So if we summarize, we are trying to find out the line. Fine. So, and based upon for these 2 points, initially scatter plot will be plotted, and a line regression, in the sense a line will be plotted. Fine. And that is plotted such that it is with the minimum distance from all the points as much as possible. Is it clear, guys?
Yes, sir. Clear.
Okay, fine. So you have somewhat similar plot also, LM plot. Okay, but see, regression plot itself we will not use in usual cases. Okay, it's a specific case. Okay, LM is also similar to that plot only, because I'm not going into details. Okay, so it will do the mostly the same work over here, but here also you can also use hue. I think here also you can use hue. Okay, so okay, I think regression directly you cannot use, but I think LM plot. Okay, so to do it is also a regression, but yeah. So over here, if you see, it has this blue line is only for the male. Okay, so for the tip and total, so you know the hue parameter by now. Okay, so it will color code. Okay, and this blue is for the male, and only for male dots, this blue is the line, and only for female, this is a line. Okay, so you can generate multiple lines based upon the hue parameter. Okay, looks like hue is available only in LM plot. Okay, but it's not. It is in this regression plot. Okay, but the basic concept is same. Fine, and after that, you have a small point called a resid plot. Okay, so actually this comes under this section, guys. Okay, so when you see here, so over here we have, right, so we have multiplot. Fine. So if I take a small box over here, fine, so you have also regression plots. Over here you have regression plot, LM plot, and resid plot. Okay, resid plot. So we have covered regression plot, LM plot. Okay, so now simple resid plot is, see, resid plot is nothing but the residuals. Okay, residuals. Now what is residuals? Residuals are the error, guys. Okay, so now when I come over here, so if I just give you an example, so you remember we got a line. Okay, so now let's say we have a line over here. Okay, now this line is fine, but now the problem here is this line obviously is not passing through all the points, so it is going to have some distance from few of the points. Actually majority of the points it is having some distance. Okay, only this point it is passing through. I think properly it is passing through only this particular point. Okay, remaining every point it is having some distance. Okay, giving everyone this called distance. Now this distance is also called as error. Okay, and this error is also called as residual. Okay, now what is the background of this is, now actually what does this mean is, see guys, these points are the actual points. Okay, these points are what? These points are scatter plot. Now scatter plot is coming from where? Data. And what is the data? Data is total bill and tips. Agree? This forget about this line. This scatter plot is coming from the actual data, and this is the actual points. Now this line is not present from the data. Line is we are generating. The algorithm is generating. Agree? The line is we are generating. Now, since this line is not passing through all the points, it is meant that it is making some error. Okay, the ideal goal is to pass through all the points where the error will be 0, but since it is not possible to pass, so it is passing through some points, and this is the best line which we get. Okay, let's say this line, whatever the line you are seeing here, right? This line, that line is this one. Okay, and this is the best line which we can get. And if we change this line, the distance will increase. The minimum distance is achieved by this line only. Okay, fine. But even this line, you are having some errors there. Okay, the distances, for example, if you say this as distances, I am calling it as errors. Okay, these all these distances, if you calculate whatever you get d, this is an error which we are having. Error from what? Error from the actual data. Okay, now this error is also called as residual. Fine. So don't worry, all these terms we are going to discuss in good detail when we are discussing linear regression. That time it will be extremely clear. Okay, but as of now, just understand whatever the distances you are calculating, you are having, right? So this distances is also called as error. Okay, and these are also called as residual. That residuals, if you take and if you plot, okay, if you plot, so this is a diagram. Okay, so see, some of the points are above this line. Okay, some of the points were above this line, and some of the points are below this line. Okay, this distance will be positive, this distance will be negative. Okay, we'll see all those. Okay, but as you can see, so for example, this is a line sign. Fine. So for each and every point, okay, so for each and every point you see here, okay, each and every point you see here, there will be, for example, this line, okay, without a parameter. Fine. So see, this is a residual. Okay, let me use the word residual. Fine, or error or distance you can say. Okay, now this is its residual, this is its residual. Okay, this is its my residual. Okay, this is my residual. Getting, guys? Fine. So these values, okay, so these values, when you start plotting in a graph, okay, so it will become like this. Okay, the line which you see, it will assume this is my line. Okay, if at all this is my line. Okay, that means what? Residual is 0. Okay, 0 in the sense what? All the points which are on the line. Getting, guys? There are few points. Okay, there are a bunch of points. See, there are a bunch of points which are actually falling on the line. Okay, for those the distance is 0. That means error is 0. That means residual is 0. Fine. So those points are over here. Okay, those points are over here, which are on the line. Okay, and some of the points are above. Okay, some of the points are having above the line. Okay, so all these points, okay, all these points are above the line. Okay, and they are having some distances from the line. Okay, and some of the points are below this line, and they are having some distances which could be we can consider as negative distance, and this could be considered as a positive distance. Okay, so the same thing is happening over here. So here it is saying wherever you are having 0, that means this is a 0 error, 0 residual. That means wherever you see the points over here, that means all these points are actually present on our line. Okay, and all these points are above our line. They're having some positive distance from our line, and all these points are having some negative distance. That means these are below our line. Okay, so in other words, you can see the same diagram, they have tilted it. Okay, they have just, if you assume they have tilted it 50 degrees, 80 degrees, sorry, 50 degrees, 40 degrees. So you will get this graph. Am I correct? No, I'm wrong. Okay, so no, it's not about the tilting, it's just the distance. Okay, so that means what? Each and every point, okay, each and every point. Now let's say this point distance is 3. Okay, this point distance is 2, this point distance is 1.1. 1.5. Okay, like that you calculate these distances. Okay, and similarly also below also you will have some distances. Okay, now take the distances and plot here. Okay, see, for example, this is some point whose distance is 4 from the line. Okay, this is from 2.5, 3.5, like that. This is -3, -2, -2.5. Getting, guys? No? Residual, not understood? See, if you can't say, I can understand. So I'll assume you guys understood it. Okay, fine, great. Everybody understood residual point. Okay, fine. So next thing is we are going to see. Okay, next thing we are going to see is called as facet grid. Okay, see guys, in the starting of the session, I have discussed that facet plots. Okay, see guys, even if you don't understand residual at this point, okay, don't worry, we are going to come back in our first linear regression algorithm. Okay, but at least I hope you understood the regression plot. Can I assume that you understand regression plot?
Yeah, Santosh.
Okay, fine. Okay, so you go through the class once again. It should be clear. Okay, it's not that difficult. It's just an error you're plotting. Okay, but even if you don't understand, we'll come back. Okay, so just as of now, just understand regression plot. That's fine. Now coming to facet grid, facet plot. Okay, that the way how you can plot facet plots, two ways. Okay, one is facet plots and another thing is facet grid. Okay, now focus here, guys. Okay, these will be interesting. So if you see, the way how you're going to draw the facet plot is simple. This is how you're plotting the facet plots. Okay, how you're specifying the column and row. Okay, and this is my categorical plot, and what category I want. This is my violin category, and this is my data X and Y, and so on and so forth. Okay, so row column I'm taking day. Okay, that means what? In day you have Thursday, Friday, Saturday, Sunday. So each column is for one row. Okay, and row I'm taking time. Time is either lunch or dinner. So each row will be lunch and dinner. Okay, this is for lunch and this is for dinner. Okay, so this is simple facet plot. Any doubts in facet plot? Here you don't have any combination. So here it is empty because there are no data for this combination lunch and Saturday, because Saturday they did not come for lunch, they came only for dinner, and also Sunday also only dinner. Okay, and Thursday they did not come for dinner, they came only for lunch. Clear?
Yeah, Santosh.
Now the other way of drawing this facet plot, okay, so is actually using facet grid. Okay, so over here if you see how you can draw the facet grid is, see, G equal to SNS dot facet grid. Okay, now SNS dot facet grid, first you need to take the SNS dot facet grid, create an object called as G. You can give any name. Okay, so over here you need to specify the data and also your column and rows. Okay, this column and rows are specific to facet plots, right? So you need to specify. First you need to create this object. Okay, see guys, SNS dot facet grid, data, column and row. You need to first create this object. That's it. G is my facet grid object. Okay, now if you see this G, that will be an empty grid sort of thing. Okay, see, this is my empty grid. Okay, now it is just giving you the grids. That means what? So for column, it has considered time. Okay, lunch and lunch. This is all for lunch. Okay, this is all for dinner, as you can see. Okay, and column it has given for day. Okay, Thursday, Friday, Saturday, Sunday. Okay, it has created a grid object. Okay, now this G is a facet grid object. Fine. Now once you do this, next you need to add whatever you want to add to this grid. Okay, I think this is similar to, if you remember, axis level and figure level. Not axis level and figure level. It is similar to subplots. You remember there are two ways of plotting subplots. One is creating the subplots directly, or creating the object and then adding the subplots as and when required. Does anybody remember these two approaches? subplots. Okay, fine. Okay, but we have discussed two ways of drawing a subplots. Okay. Now SNS.facet grid is when you do this G, this is a simple, it will give the grid. Okay, inside this, now it has created the platform background. Okay, so these are 8 graphs you will have. On each of this graph, what do you want to draw? So I'm saying using this G, I'm saying G.map. Okay, map. Inside this, you are saying draw this plot. Okay, I'm saying SNS.while plot. Okay, with 6 and total bill columns, I want to draw. Okay, and this is a legend. Okay, it is just adding this. Okay, so now if you see, this is a graph. So it has created the grid and also it has drawn while plot. Okay, see, it has drawn while plot. Fine. And for what? For my X is for 6, that means we'll have male and female, and this is my total bill. Okay, now over here also you are going to have on the y-axis, we are going to have total bill. Okay, and this is for male, total bill, female. Okay, male, female. Okay, like that. Getting? That means what? So this graph is the while plot of male visitors. Okay, and the graph is for the total bill that has collected from the male visitors who has visited on Thursday for lunchtime. Okay, this is a while plot. And inside this while plot, what is this? This is a box plot of the data. And this is what? Can someone say this is what in while plot? While plot is combination of what two plots, guys? Box plot and
KD.
KD, right? Fine. So this is KD. Okay. So these are the different combinations you have over here. Fine. So first it will filter on what to draw this graph. It will filter on the given dataset tips dataset. Will simply put filter. I think you know filter conditions. Okay. So you can do it multiple ways. So just put time equal to lunch and day equal to Thursday and 6 equal to male. Okay. You will have some certain data. Fine. So using that data, okay, using that data, you just plot this diagram. Okay, so you will have box plot. First you will draw the box plot and the KDE, or simply when you say while it will draw the both. Okay, now this is a combination of while plot for male visitors on lunch and Thursday. Okay, similarly this is for female on Friday lunch while plot. Okay, fine. So that's about the facets. Yeah, okay, so you can also have okay, so here you have, see, bivariate analysis histogram. So today initial few minutes we have seen. Fine. So this is for the histogram for male and total bill. Okay, so for male, what is the plotting, and for the female, what is the plotting? Okay, if I see something like bar plot, do we have bar plot? Okay. Yeah, so this is for bar plot. Okay, so like that you can draw. And also using the scatter plot, you also have the parameter called as, you can also introduce the parameter hue. Okay, so same thing, SNS.facet grid. Okay, so I am creating object. On this object, I'm adding the map. Okay, so here I'm drawing a scatter plot on tip and total bill. Okay, and x-axis will be tip, y-axis will be total bill. And but here I'm also want to segregate with the color code hue smoker. Okay, so that's how you got. So if you see this graph, and male is this is for male and this is for female. Okay, and what happened, this is for Thursday lunch male visitors total bill scatter plot, and orange is for Thursday lunch female visitors scatter plot. Okay, and here you are having the legend. Okay, smoker, this blue is for yes. Okay, sorry, it's not male and female, I'm sorry, it's for smoker. Okay, hue. Okay, so this blue is for smoker and orange is for non-smoker. Getting guys?
Yes, Santosh.
Okay, so that's how you can draw different combinations using the facet grid. Okay, so it's same as facet plot, only the only way is how you can generate is bit different. Okay, fine. So after that you have I think we have covered, yeah, so I think we have covered regression, LM, residual plot. Okay, and facet plots are done. Okay, the last section which we have is called as multi-plot. Okay, it's a pair plot and joint plot. Okay, so let's see those. Okay, so looks like we're gonna, yeah, fine. Okay, so now coming to pair plot or pairwise plot. So here also you have two types which we can do. One is direct pair plot and other one is pair grid. Okay, so first of all, let's try to understand pair plot. Okay, so it is, as I said, it is very important plot, and this is one of the first plot which we will draw in most of the algorithms to understand, okay, the relation between each and every column against each and every other column. Okay, so that is a importance of this graph. Okay, so fine, so let's see. Okay, oh, okay, so today we have college.
Tomorrow also we have.
Sorry.
Today and tomorrow we have, sir.
Oh, today.
CRP training.
Okay, fine then. Okay, so tomorrow let's continue with this join plots and pair plots. Okay, fine guys, thank you so much. Chalo, bye.